This video will be talking about 1.1 Objective 4, where we identify symmetry in functions, equations, and their graphs. Let's go ahead and look at question 1. State whether the functions represented by graphs A, B, and C shown in the figure to the right are even, odd, or neither. So let's start with A. A is an odd function. I'm sorry, A is the black function. So A is an even function. It has y-axis symmetry. B is the pink function, and C is the blue function. So A is even. And B is going to be odd, and C is also going to be odd. So even, odd, and odd. Even, odd. Okay. Determine whether the graph of the following equation and or function has symmetry about its x-axis, y-axis, or origin. So because it's solved for y, we know that it can't have x-axis symmetry. It's a function here. So that eliminates the x-axis possibility. Y-axis, we're going to stick in negative x, and we're going to see that this is x to the fourth plus 3x squared plus 8, which is the original function. So the function is going to have y-axis symmetry, which is A. Now we want to determine whether the graph of the following equation and or function is symmetric about the x-axis, y-axis, or origin. Again, it's solved for y, so we know that it's not symmetric about the x-axis. And when we find f of negative x, we have x to the fourth plus 7x squared minus 8. So this is again symmetric to the y-axis. F of negative x here is negative 3x to the third plus 3x minus 5. And that's going to be neither even nor odd, so it's not going to be symmetric to the x-axis, y-axis, or origin. It has no symmetry. F of negative x here, that is the same problem, just without making me find what f of negative x is, so it has no symmetry. 2 times the absolute value of x, that's an even function. It's symmetric to the y-axis. Everything on the left-hand side is odd, but on the right-hand side, there's no odd power over here. It's going to be neither because that's not right. These are even. Let's go ahead and plug it in. 5 times negative x raised to the 4/3 plus 9y to the 4/3 is equal to 9. And take the cube root of negative x. It's the negative is going to go away because there's 4 of these. So this is going to be 5x to the 4/3 plus 9x to the 9y to the 4/3 minus is equal to 9. So it's going to be symmetric with the y-axis when I replace x with negative x. The same thing is going to happen when I replace y with negative y. And when I replace both of them, in all cases, I get the same thing back out. So graph is symmetric about the y-axis, the x-axis, and the origin. This was my test for y-axis symmetry. This was my test for x-axis symmetry. This was my test for origin symmetry. Right. An even function plus an odd function, there's going to be no symmetry to it. Some things will change sign and some things won't. An even times an odd is going to be odd and will be symmetric to the origin. An odd function composed with an even function will be symmetric about the y-axis. We'll take on those properties of that even function. And same thing with an even composed with an odd like this will also be symmetric about the y-axis. That odd, this will always be quote positive, and so when I do the odd function of it, it's gonna come out to be positive, so that's even, and this even will take care of this negative from in here and flip it to positive, so that's going to be even. All right, that's it for this video. We'll come back next time and we will solve applications involving functions. See you for the next video.